Broadcast is now starting. All attendees are in listen-only mode.
Morning, folks. It's Dan Kane with HazTek. So they're in, our group is in listen-only mode. How do they respond with questions? Bridget here is monitoring.
Hi, yes, this is Bridget Robinson from HazTek. So you are automatically muted and in listen-only mode. However, you'll see a little hand icon next to your name. You can click that if you want to raise your hand to be unmuted. There's also a chat function towards the bottom of the page if you want to send Dan a question that way as well.
So that means they would type their question in, Bridget, if they click on that?
Yeah, they can type their question in and it will pop up for you.
So when you say that, you're talking about which function is that in that?
It should be towards the bottom of the bar. It says chat, and if they click that down, they can type a message in right there.
That would be right here. Okay.
Yeah.
Okay, so we have, shall we get started? Okay, folks, my name's Dan Kane. I'm a principal consultant here at HazTek, and I'm a subject matter expert in fall protection. I'd rather call myself a fall protection nerd or geek. One of the classes, there was recently a national safety stand down week. It's a OSHA program, and of course, preventing falls in construction. So one of the most requested classes I had was, could you come to our job site, talk to us about self-retracting lifelines, retractable fall limiters, yo-yos. There's a growing trend in the industry right now for some of the major construction management firms to have a lanyards last policy. It's sort of a take on the ladders last policy that Turner Construction sort of put to the forefront several years ago. And in fact, in the Philadelphia region right now, I just attended the Mid-Atlantic Construction Safety Council last Friday, and companies like Hunter Roberts and HSC and LF Driscoll, Intech, these are just to name a few. There's a consortium of these safety directors that are meeting to talk about implementing a lanyards last policy. In other words, they're going to require to use retractables on their jobs. So there's already a handful that exist right now. Some of our end user clients already have policies. So as we start to investigate these things, we're finding out that they're not all equal. There's some distinct limitations to how some of these things can be used. In other words, there's not an adjustable wrench when it comes to self-retracting lifelines. You see, I put in here SRDs. This is a new term created by ANSI, the American National Standards Institute. It's an agency that is a regulatory or crafts, not really a regulatory, it creates standards that OSHA intends to adopt in some way, shape, or form in totality or partially. Creating a lot of confusion, this group, this standard in the industry. It's meant to try and create standardization, hence the term standard. And so what's happened is it's sort of taken a little bit of it's morphed differently. So today's program is going to talk a little bit about some of the key differences and understanding these key differences so that you can, if you're using this device, how to use it properly, how to minimize your risk, because people are using it, they're still getting hurt. The level of injuries and perhaps fatalities not going down despite theoretical improvements or improvements in technology. In fact, I just was visiting a client about a month ago that a person fell and the cable on the retractable snapped and the employee hit the ground. about a week and a half ago, I was served with a subpoena to give testimony in a case where a company employee fell, his retractable snapped and then disengaged from the anchor point. The retractable almost fell and hit him in the head when he landed on the ground. So I had worked for a company called Diamond Tool. I created their safety division about 15 years ago, and I guess one of these companies named in the lawsuit thought that maybe we provided the equipment. We didn't, but you know the way that goes in this litigious society that we have. So, but in any case, let's talk a little bit about some of these devices. And I'd encourage you, if you have questions during this process, you feel free to unmute your device and chime in, and we'll see if we can answer it. Or we're typing that chat mode, and Bridget will bring the question to me, and we'll see if we can answer it. I can assure you it's going to add value to this program. So we have 45 minutes today. If you want my name and my phone numbers on here, my email address, you feel free to ask any questions during or even after the program. That's what I'm here for. So I probably know some of you or talked to some of you over the years, maybe not, but love to be able to help you out with your questions, folks. So again, the title, not all SRDs. So this term SRD might be new to some people. SRLs, it's not advancing, Bridget.
Click on the screen.
Oh. There we go. Okay, so thank you. So this webinar thing is fairly new to me, so just please bear with me as we roll through this. So again, self-retracting device, what we call them in the field, fall limiters, SRLs, yo-yos, retractables, blocks. These are what they look like. It might be a mini, which is a personal fall limiter. Now we see the 100% tie-off. The first device is a 6-footer. The second one is a 9-footer. And they come in different shapes and forms. This is just one manufacturer. Small snaps, big snaps, depending on what you're attaching to. There's even different devices that get attached to your back D-ring. Standard cable units, 20-foot web units. These are all the pictures of different devices you'll see. They come in all shapes, sizes, and colors, right? But right now, the industry was supposed to standardize based on this ANSI classifications. This is not OSHA doing this. This is ANSI. And if you look at who the members of the ANSI committee are, they're primarily made up of manufacturers and some engineering people that make their money evaluating anchor points and providing site visit consultations. The ANSI standard is a family of, right now it's 6 different components. They call it a family of standards. And only one of those is related to self-retracting devices. So, and it sets the performance requirements of it. So we think of it in terms of Class A retractables or Class B retractables. So if you're using a retractable right now, and if it was made anytime in the last 5 or 6 years, on the label of it, it's going to tell you whether it's a Class A or Class B. So what that means is Class A retractables are going to have a max arresting distance of 24 inches. So in the past, we thought of these things as instantaneous stopping. Well, it's never really been instantaneous. There's a speed at which these things engage or activate. So there's a braking system, a locking system inside that's going to stop us. So think of an anti-lock braking system in a car. If you hit the brakes on it, it's not going to stop you immediately. Your rotors are going to pass through the brakes, and they're going to bring you to a soft-controlled stop. So there's a lot of factors involved in that. But in this case, the factors that are involved are, when we say maximum arrest distance of 24 inches, that is now engagement. So the length of time, or the length that it takes to engage the braking system and then deploy or activate. That's going to be 24 inches when tested in an overhead condition. Class B can be 54 inches. So some people, I geez, just about every day I run across people that think, hey, I'm using this retractable and it's going to stop me immediately. Well, it's going to engage, then it's going to be deployed because there's some shock absorption to it. Well, that's 4.5 feet. Some of these things can, let's say, pay out. So you have to think about that as you use it. And again, this is for overhead application. So the other factor that we got to think about is a Class A retractable, because it stops so fast. There's very little energy absorption in it. I have a maximum arresting force of, a maximum average arresting force of 1,350 pounds. So Class B, because it has a little better energy absorption, it dissipates the shock load better because it deploys longer, is going to have an average arresting force of 900 pounds. Maximum. That gets to be important when selecting anchor points. This is not a course about anchor points, but most people are told that an anchor point has to be capable of supporting 5,000 pounds. They fail to consider, or most instructors that teach this really don't have enough experience knowing that, hey, the standard has a provision for 2 anchor points. It's actually within the same paragraph of the OSHA standard. It shall be 5,000 pounds or shall be designed to a 2-to-1 safety factor as part of a complete fall arrest system and shall be designed by a qualified person. So an example of this is I go down to Wilmington, Delaware, and there was a restoration project of a historic building, the Queen Theater. And they were struggling to find an anchor point in the carpenter, the roofer, the abatement contractor, were all in it sort of together, and that they were peeling back this roof that had asbestos on it. They had to reinforce the structure, so they needed something to attach to during the tear off, the reframing of certain portions of the structure, and then the re-roofing of it. And the engineer for the engineer of record for the building said, I can't give you an anchor point 5,000 pounds. They didn't know what to tie off to. So I said, let's look at our retractable lifeline, and let's look at the way that we use it. If we have a retractable lifeline as a Class B retractable, and we can limit fall arresting forces to 900 pounds, can you certify an anchor point to 1,800 pounds? He said, that I can do. Now, if we selected a Class A retractable, he's going to have to certify the anchor point, take 1,350 times 2, to a 2-to-1 safety factor. So we're starting to see more and more of this as we start to see more and more value engineered structures. In-house, if you're doing any industrial work and you're inside of certain facilities, and the structure that you need to attach to get your work done, so you're putting a mezzanine in or doing some punch list work, and there's a lot of equipment hanging off the ceiling structure that you want to attach to, say a bar joist or something like that. Well, some of these facilities are saying, you got to evaluate the anchor point. We're not sure it could support 5,000 pounds. So they have an engineer come in. We actually provide this service to look at it, say, all right, what device am I going to connect to that's going to limit the fall forces so we can get this thing looked at by PE to say, hey, I can attach to this structure. So we're starting to see more and more of this creep into the construction environment. It's kind of there right now for the general industry environment because the ANSI, a lot of these facilities in the pharma world and the chemical processing world choose to conform to ANSI standards rather than OSHA. And oh, by the way, it's there right now. If any of the interior finishing contractor clients, any people in this, if you're doing any type of Department of Energy work or DOD work, there's still some areas down in the Navy Yard that are Department of Defense or Army Corps of Engineer work. Those standards, the EM 385 fall protection standard that these facilities conform to the ANSI standard, not to OSHA. So it's there already, in case you're doing any of that work. We see that, by the way, in areas where you have like a waste management site that might have been a Superfund site at one point, and there might even be, you might have an area where only 20% of that facility is declared Superfund and conforms to EM 385. Well, guess what? You're conforming to these standards. Just out of curiosity, I can explain that in some detail in a later conversation. So in this ANSI standard's kind of weird, and I don't want to dwell on this, but it gets funky because it actually has a max arrest force for performance requirements of 1,800 pounds. So that gives the manufacturer some leeway, right? They even have some testing for what they call environmental conditioning. This would be wet or hot or cold environments, right? I won't bog you down with those details. But there's also another thing that's going on, which is called an SRL-LE, and that's a self-retracting lifeline leading edge version. And here's some pictures of 3 different versions of it. If you start left to right, you're starting to see the minis. These are sort of personal leading edge retractables. You see the device called the NanoLock. Those are personal. They get attached to the harness below the back D-ring in most cases. And you see the gray and black device, that black pouch that's sitting behind that gray reel, that little retractable, that's a shock absorber. And if you look at the orange device, that's orange and black, the NanoLock, you sort of see that split where it says SALA and NanoLock. That gets attached to the harness underneath the back D-ring. That's a shock absorption device. So that black pack and that orange pack, those are external energy absorbers. So these devices have internal energy absorbers in the reel, and then they have external energy absorbers. So if you look at the big red device, that's a Miller Falcon leading edge. So that has an internal centrifugal brake system that has a clutch plate energy absorber. And then you see the black pack, which has an external energy absorber component to it. ANSI standard wants an external energy absorber to follow the worker over the leading edge or unprotected edge. This way, when the cable or the web of a unit comes in contact with the leading edge, that there's an extra shock absorber that's going to take the pressure off of that pinch point, going to prevent the cable or the web from snapping. That's what we're finding. You're going to see that in a moment. I've provided one of the manufacturers, 3M, which is DBI Capital Safety. They've done a really, really good job of showing a video of what happens in a leading edge environment when a cable catches a leading edge. We also have sharp edge, leading edge. We'll get into that in a moment. But what's a leading edge retract? Here's another version of it. That's the new 3M Smart Lock. Pretty cool device. It's actually has a magnetic system in it to prevent the cable from getting sucked back in too fast and popping the fall indicators. There's an anti-nuisance locking feature. The diagram to the right, are there any questions, folks, as we keep rolling through here? No questions? We'll keep going. So what's an SRL-LE? What's the difference between a standard retractable lifeline that we use every day and a leading edge version? Well, leading edge version has to pass a test where they raise the test weight 5 foot above the walking working surface. And they drop it. In fact, so there's a straight line drop component to it, and then there's an off-center drop to it. And they drop that test weight, and they want to see if the cable's going to snap or the webbing's going to snap and hold, rather than just simply doing if the overhead was attached, if the retractable was attached overhead in a straight line drop. That's an easy test for that retractable to pass. Not so easy when the test weight is raised 5 foot and you have increased fall distance. Okay, so it's got to pass that test. There's also some labeling requirements. You're required to follow. They give you more information on the do's and don'ts on how to use this retractable. So you see diagram A is an okay situation. Diagram B is an okay situation. C is a no. So if anyone's used a retractable lifeline tied off at foot level, say on a roof cart, I think someone from Hagen is in the group, and I remember Hagen using, say, roof carts on an HSE project where they were installing roof guardrail systems. Well, if that roof had a parapet and your retractable lifeline was attached to the roof cart, sort of dangling just about foot level, and there was a parapet on that roof, and that parapet was, say, 12 inches high, well, that would be a no-no. You wouldn't be able to use standard retractable attached at foot level. Now, some of these roof carts now have SRL trays, and they attach to the roof cart, and they elevate the retractable about 10 inches from the roof surface. So if you had a 6-inch high blocking on that roof edge, well, guess what? Now you're okay. Now your angle of redirection is not outside the limits of what the manufacturer sets. So safety people are getting better at recognizing this, folks. But what happens is you're going to have people today that have no idea of this. They're going to sit through one of these seminars and the light bulb's going to go off. So how they enforce your job tomorrow could be different than how they enforce it today. In other words, oh, you let me do this last week, but what changed this week where you're saying, hey, no, I got to stop and I got to do this, 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 and this. So you just shut my job down. All of a sudden, there's this tremendous amount of friction between the safety director who thought was okay with what you were doing last week and what he's doing and what he's not allowing today. That means his level of knowledge and now his expectation is different. So be aware of that, you know. But our purpose for doing this today is so that you're ahead of it, not behind it. So someone like Randy at University of Penn, you go through this seminar today, walk your job last week and walk it next week, and all of a sudden what he's expecting from you is going to be different. So forewarned is forearmed in this business. Here's another example on an interior application. So I gave this presentation a few weeks ago, and a safety guy was leaving the meeting, going on the active job site to prevent a situation like this from happening that he knew was already happening. So you see where the angle of direction is greater than 90 degrees on the bottom diagram. The top's fine, bottom not fine. So your anchor point selection is important. The location of that selection is important in this situation. So observe the setback distance requirements. So someone says, what's setback distance? Well, here's a perfect example. So on these leading edge retractables, you're going to find some of them have a 2-foot setback distance requirement. Some are going to have 1.5 feet, and some are going to have none. But you need to be aware of that. So we talk about SRL, LE. We talk about we need the discussion needs to go from what's a leading edge and what's a sharp edge. So some retractable lifelines are leading edge approved, but they're not sharp edge approved. Some are leading edge approved, but only for overhead tile. Some are leading edge approved for foot level tile. So this is where I said at the start of this presentation is the standard was supposed to eliminate all this confusion. It was supposed to sort of standardize the terms. And now all the manufacturers sort of run in different directions. So you really need, folks, I've been in this business for more than 25 years, I think 28 years at last count, and I spent half of them working for fall protection manufacturers. I'm putting together a presentation for a major pharmaceutical client. I am talking to engineers inside of these different manufacturers, and I am getting different stories and different takes on different things from engineers within the same manufacturing company. My point is that this is a moving target in a way that I have never seen before in my 28 years of business. So this ANSI standard for retractable lifelines came out in 2014, I think it was, and they're going to revise it again because they're going to get this committee is getting together again. And they're saying we're all confused again. We're creating, I don't say mass confusion, but they're creating some confusion in the industry that doesn't need to be there. So you're going to see these terms revised again. You're going to see, I think, a greater consensus. But the takeaway from this slide is if you're going to use a retractable at foot level and you're going over concrete deck like you see C, metal deck in B, or even a beam flange in A, you better be using a leading edge sharp edge. So you better be using an SRL LE that is sharp edge rated and approved. Okay, so that's a roof condition. That's virtually any deck condition. In fact, you're tying up at foot level, you're definitely using an SRL LE, and you really should be using an SRL LE that's sharp edge rated. But you need to know that when you tie off at foot level, that there's some performance characteristics. So this video is going to show you what can happen if you select the wrong retractable and you use it. So 3M DBI, we used to say DBI was the Mercedes of the business. They're somewhere between the Mercedes and the Lamborghini of the business. They probably do make the best devices. They support the product in an extremely good way. I would put Miller Fall Protection up there as one of the top rated fall protection companies. I think technically speaking, DBI is even a level above them. You know, Miller would be more of the Chevy or the Ford of the business, and 3M DBI is going to be more of the Mercedes. They have a brand that they own, 3M, which is Protecta, and that's going to be more like the Toyota Corolla of the business. Pretty good, pretty sound, you know, but not revved up, you know. Are there any questions before this video is going to be, I think, about 4 minutes long. I don't normally like to put videos or embed videos in it, but this is just too good not to share. Any questions before we click go? Give me a moment. Okay, let's play this video. I think it's pretty cool. At the end, we might shorten it up by 10, 20, 30 seconds. But let's. The DBI Nanolock. The white strap is the external energy absorber. So that's giving you the technical definition of what a sharp edge is. Technical. One of the best lanyards on the market right there. And it can't survive a leading edge fall. DBI Nanolock, one of the best personal fall limiters on the market. External energy absorber didn't even get a chance to pay out. It snapped before the energy absorber was engaged. Ultralock. Almost. Almost. Ah. A little drop off center. That's the 5 foot off center drop it has to pass. That's an awesome retractable lifeline too. Just not approved for foot level tie off, leading edge. These D-ring extenders are extremely common. Should not be used with leading edge retractables. Didn't take much. So here's an example of the DBI Smart Lock Leading Edge Retractable. Usually a larger cable diameter, but certainly the external energy absorber. Well, I'm sorry, nano lock. You see that white pack deploy? That's the external energy absorber. There's the smart lock. That has the best clearance heights in the business. It pays out less than just about any retractor. Okay, so any questions on the video, folks? Pretty interesting what happens to a lanyard or a retractable when it's not SRLE rated. I've been at this, like I said, 28 years, and I've been the director of sales of 2 different fall protection manufacturers. And I will tell you, at least once a year, I got a call from someone that used a retractable that snapped and hit the ground. So, or the swing fall was so severe that they used it on a roof or decking application where their expanded work zone was so great that they swung and hit the ground. I had one case, same employer, someone hit the ground 1 week, and a few weeks later, someone swung and hit a column and broke his leg in half. So there's some planning that needs to occur when it comes to these SRLEs. Kind of interesting that earlier I told you about Class A and Class B retractables, where OSHA says, or I'm sorry, ANSI says that a Class A retractable has a max arrest distance of 24 inches and the Class B 54. And these devices, all right here, have some sort of labeling that's going to define it. But the interesting fact is that's when it's tested in an overhead application. When it's tested to SRL-LE testing, OSHA does not set a maximum arrest distance. So one of the issues we had is we had a client, I'll tell you, Merck Pharmaceuticals, if anyone does work there, they have a elevated work permit that needs to be filled out anytime you're working above a 4-foot elevation. It's I think it's a 16-page document that you have to fill out. And you have to draw a stick figure. You have to put in the arrest distances, the safe clearance, required safe clearance distance. And people were going to the product and pulling this data off of the label and dropping it into the work permit. But they didn't read the fine print. The fine print would tell a different story, that when exposed to a free fall distance, the arrest distance is going to be greater than 24 or 48 in every instance when tested to the SRLE standard. So be sure to read the fine print. By the way, this is a different video. This is a European test listed here. At some point in the future, I can share that with you, but that DBI version is a little bit better. So here's an example of what is really the maximum arrest distance. So I showed you the Miller Falcon Edge, that red retractable, the cable with the extra pack. And this is the specifications on the product. So it tells you a max arrest distance, overhead use, it's going to be 42 inches. That's right here, folks. 42 inches for the 20 and 30 foot models. And it's going to be 54 inches, 4.5 feet for the 50-foot models. So what we're encouraging people through training at the Merck sites throughout the country is when, so it's telling you when the SRD, when the self-retracting device is anchored overhead. So when it's exposed to free fall, this means when it's attached, traditionally when it's attached to a height that's equal to the back D-ring, there's going to be some free fall distance to it. So when SRD is anchored so that free fall is possible, max deployment, you got to read between all this print here, all this other foreign language. Maximum deployment is now 117.5 inches. So your required safe clearance distance is going to change. What does that mean? So an example would be contractor fills out an elevated work permit or tells the safety person, hey, my retractable is only going to pay out 42 or 52 because it's right on here. Well, if you've been through any kind of training, he's going to know, no, it's really going to pay out here. And now you're probably using it in a way where I can hit the ground. So you take a single story building and you think, hey, I'm only paying out this. Well, when he starts to add some swing fault to that, maximum deployment of 10 or could be 12 feet, you got to rethink how you're doing things, right? So you got to really understand. So maximum arrest distance can vary by manufacturer. For instance, HazTek Duratech, which is a very popular retractable right now in the industry because it's inexpensive. Well, that might have a maximum arrest distance of 100. Not might, it does. I gotta check my spelling better here. How about that? Maximum arrest distance 145 inches. Any questions on that so far? All right. So calculations, right? When it comes to these SRDs, you gotta, I'm not gonna run you through all these calculations, but when we start to do higher level training, which is required at these pharmaceutical plants, they're requiring the competent people to understand these terms: vertical fall distance, maximum fall distance, maximum free fall distance, maximum deceleration distance, swing fall factor, the swing radius. They're requiring these numbers to be jotted down and documented in these elevated work permits. So if you're not at these sites, what does this mean? What it really means is you just simply have to understand the manufacturer's instructions and how to apply them to your work condition, to your application, to your specific application. If you're on the Merck site, you're going to be putting this data into every elevated work permit. So you got to know the definition. You got to firmly understand it, right? So we can't just teach people anymore how to understand, hunt for the data, how to use a manual, but I can when I'm not at that site. So we're starting to do that type of stuff more frequently now. Now, this is a silly example of how do you calculate vertical fall distance for this guy, free fall distance. You know, and I still see applications like this exist, you know, where a guy takes a sling and he throws it over a beam, he attaches at foot level. He's actually anchored below his back D-ring. He's going to have a 12-foot free fall distance before he takes the slack out of his anchor sling. So he's actually going to have a free fall distance that's going to exceed 12 feet. He's going to bust his lanyard. He's going to put more than 1,800 pounds of force on it. He's going to have a required safe clearance distance that's going to probably be somewhere in the area of 18 to 20 feet, right? Not unheard of, right? But when we deal with these situations, here's free fall. Like when I'm anchored above my back D-ring, you know, depending on the height of my anchor above the back D-ring, I might only have a free fall with a lanyard of 1 foot. Now, if I'm anchored at like that, that's a diagram to the left. If I take the diagram to the center and I'm anchored at the same height as my back D-ring, and I'm using a 6-foot free fall lanyard, my free fall distance is 6 foot. But if I'm anchored with that lanyard at foot level and it's a rigid anchor point, my free fall distance is going to be 11 feet if I'm about 6 foot tall. That's assuming my back D-ring height is about 5 foot off the walking working surface, right? So I got to fall to my anchor point, fall to the end of the lanyard. That's an 11-foot free fall. By the way, not all lanyards are rated for that. So the ANSI standard is going to have a lanyard that's going to have a white label or a black label. So this is the way the safety person looks up. He says, oh, that white label is rated for a 12-foot free fall, or that black label is only rated for a 6-foot free fall, or vice versa. I can't recall what the identifiers are, but the label's going to tell you what it's rated for. So you got to select the right one. By the way, one lanyard will open up 4 foot and the other will open up 5 foot. So you got to do that calculation. In this case, our discussion's about retractables. So if you're trying to figure out, this is what you should be trying to figure out is, what's the required safe clearance distance from either my anchor point or my walking working surface, right? If I have a retractable and I'm attached overhead, this is an easy calculation for me, right? My required safe clearance distance, or what some will refer to as the vertical fall distance. So in this case, if I'm anchored overhead, directly overhead, and I fall, I really have zero free fall distance unless I kind of experience a head first fall. But that's kind of zero free fall distance. Everything in my calculation, therefore, is going to be like a 24-inch max arrest distance or a 54-inch max arrest distance with some sort of safety factor added in. So here's an example of a calculation. So what's the maximum fall arrest distance? So in this case, if I'm anchored overhead, that's going to be 0. If I have a head first fall event and I want to add something to calculation, that's going to be maybe 2. If I'm anchored at the same height as my back D-ring and I'm using a retractable lifeline and I'm at the edge and the anchor point's right next to me, the maximum fall arrest distance is going to be probably 2 feet to 18 inches. That is the bearing length of your retractable. That's from the carabiner at the top to the snap hook at the bottom. So that's taking into account the dimension of the carabiner, the dimension of the retractable lifeline, the amount of cable that stays out of that when it's fully retracted, the snap hook, and whatever hardware that's in the middle of it. And then, of course, the safety factor that the manufacturer or the client requires. So sometimes the manufacturer says, I want a 1.5 D-ring slide or D-ring shift, and I want a foot or 1.5 of safety factor. So we have one client that says, I'm not going to worry about calculating D-ring shift or slide. I'm going to tell you, you need to add a 3-foot safety factor. So you have client controls and then you have manufacturer recommendations. You need to be aware of both, depending on where you're working and what you're doing. It's not as complicated as what it might sound, right? So what we're really trying to find out is, what's our vertical fall distance? Really, are we going to hit the ground? Are we going to stay with it? This is a straight line fall. This does not include any swing fall, right? So there's a second way of calculating, getting to the same end means. What's the maximum free fall distance? What's the maximum deacceleration distance? It may seem the same. The terms are different. We use that because you have a client that might require a calculation done this way, right? You're getting to the same point, which is the vertical fall distance and your required safe clearance distance, okay? So one of the things we tell people, when you're anchoring overhead, you have multiple fall clearances. So that's dependent on your worker height. So if you see the picture to the left and the picture to the right, in both these cases, technically we have 0 free fall distance, but our required safe clearance distance is going to be the same, or I'm sorry, going to be different for the guy to the right than the guy to the left. The guy to the right falls, if he's using an ANSI Class A retractable, he's going to have a max arrest distance of 24 inches, some D-ring slide, and then whatever safety factor we want to add to it. The guy to the right, his anchor point's lower when he's working. His body's crunched up, right? So the body's got to unfold. His legs have to straighten out. His required safe clearance distance is going to be 3 foot, probably 3 foot greater than the guy on the left. So some of the manufacturers are doing a good job of explaining this in their product manuals, some a poor job. But we have clients now that are saying, you need to tell us in your elevated work permit if there are multiple fall clearances. Is the guy working standing, or is he working on his hands and knees, kneeling in a crouch position, or even lying down? So we've had people lying down on their back and lying down on their belly, and guess what? The required safe clearance distance can be a little bit different for each one of those scenarios. So this is getting to be, this is, now you understand probably why I say this is a moving target more now than ever. It's getting more complicated, but by the way, OSHA does this stuff. When you have a more sophisticated compliance officer, they will be doing this evaluation. And I have had clients that have had, not to say injuries, but have had citations for exposing workers to an event, a fall event where they could hit the ground because OSHA has someone that can do this calculation and the client did not. And they're getting an argument about it. So I've had that happen. Certainly over the last 15 years, I've had a handful of those come to my attention. Right. So vertical fall arrest distance is a calculation for the worker orientation, right? So you're going to calculate your maximum free fall distance. If it's zero, it's zero. You know, your maximum deceleration distance, your safety factor, and then the final factor is just a simple adder. Is the worker kneeling down or is he lying down? Lying down on the back. If he's lying down on the belly, you could use maybe a 4-foot adder instead of the 5-foot adder. Okay. Some manufacturers don't discern that. They just say lying down is going to be 5. Add 5 foot to your required safe clearance distance. Okay. So what they want can vary by manufacturer. If you're using a Tech retractable, use theirs. If you're using a DBI 3M retractable, use theirs. A Miller retractable, use theirs. Okay. So and the final factor is going to be swing fall. You know, swing radius. So if you're anchored overhead or even at foot level, you need to be aware. OSHA says you need to minimize the effects of swing fall. Some people would say you need to eliminate it. You can't totally eliminate it, but you could have as much serious injury as a result of swing fall as you do from hitting the ground. So any of you aware of the trend in the industry to go to these cask hard hats, these $125 and $90 hard hats? They are side impact hard hats. What's happened in the past is contractors have had this experience with people falling, swinging into a column, whether it be concrete or steel. The hard hats get fall off in the process, and they strike their head, and there's been serious injuries. So these European style or rock climber or rescue style hard hats with the 4-point suspension with the chin strap are the rage of the industry right now. Hunter Roberts requires it for elevated work. LF Driscoll requires it for elevated work under certain conditions. So you're seeing that trend. You're going to see it continue. So, you know, and these are really as a result of swing falls, these client controls. So you need to understand your swing fall obstruction. So one on the left, I had that situation occur, I can't tell you how many times in these experiences where I walk a building and someone's calculating their required safe clearance height from the walking working surface to the lower level, and then there's gang boxes or there's scissor lifts or even people, an active work zone below it. Well, folks, if there's an active work zone below this, your required safe clearance height are to the people. And about 10 years ago, I was sitting with a safety director for Cornell Steel, and they had a guy fall through some metal decking, land on another guy, knock him down, push him, the innocent bystander, into protruding rebar, knocked his helmet off, and pierced his skull. But by the way, the person that fell had no injury whatsoever. They popped right back up. So the worker below broke his fall. So you need to take it seriously. And a lot of people don't, or they just never really were challenged to think of that. So, you know, go forth today and think about those situations. So manufacturers oftentimes will give you a clearance height chart in their product manual, but they want you to add the swing fall factor. So what is the swing fall factor? What's the adder to that? How do you calculate it, right? Simple math, right? This is high school, so a lot of us never used this since high school. This is the Pythagorean theorem. This is how you do it. A squared plus B squared equals C squared. So, so that's your C squared is going to give you a certain dimension, and you're going to back out your A dimension, and that's going to give you your swing fall factor to add to, say, one manufacturer's required safe clearance. So you have to know how they're calculating, right? If you can't use the chart in the manual. So C minus A equals your swing fall factor if you're using a Miller Falcon or Falcon Edge. And then that's going to be the number that you're going to use. So they give you a straight line worst case scenario in a standing position. And you're going to add your swing fall factor. And then you're going to add your worker orientation number. Standing, kneeling, crouched. That's how you're going to get your required safe clearance distance. Right? So here's another pictorial example of how we get to that. Maximum free fall distance, maximum the acceleration distance, your safety factor, and then your swing fall factor. And then again, if you need to add an element which is for your worker orientation. One of the things I did a couple of weeks ago was I developed a swing fall calculator. I'm not going to run you through it because it's still being finalized, but if you go to a Miller manual or a DBI or a 3M, you're going to get different charts and different means and methods for calculating. So we have a client that said, can you simplify this? So we have right now this is in an Excel format. In the future, this will be in an app form that you can purchase or some way maybe we can make available where you can plug the data in, which is your anchor point height, if it's elevated at foot level. What's the setback distance from the edge? Your expanded work zone. So that's the distance you're moving laterally away from perpendicular. You add these, and then it gives you your required safe clearance height calculation. So we want to come up with a means and methods that is simple and that, oh, it's from the working surface, because that's what happens. People think, oh, I have a required safe clearance distance of 20 feet. Well, that might be from the anchor point height. And that anchor point height might be 10 foot above my walking working surface. And I'm thinking it's from my walking working surface height. So these are all different ways of being confused. So, folks, we went a little over time. I apologize for that, but this is a segment. This is a little bit more complicated segment. I didn't intend to get into all of this during our presentation, but this is examples of foot level tie off. This would be an example of someone taking data off of a label and saying, hey, I'm good. My required safe clearance height is only 14.5 feet and my working elevation's 15 feet. And then they realize, hey, I just used this leading edge retractable, and I made an assumption that I used a class B and it's only going to pay out 4.5 feet. You can't assume that, you know. What happens if that retractable really pays out 54 inches and then has an additional payout of 6 foot for the shock pack, right? But I said with that the Miller leading edge retractable can have a 117.5 inch arrest distance. Now my required safe clearance distance is actually 20 feet. My building elevation is 15 feet. That's why you see the ambulance coming. Boom, boom, boom. Can't use it. So I'll end it here, folks. And I know I rolled through this subject matter pretty fast, but my hope is that when you use these retractables, you think about using them at what's the anchor point height? What's my work excursion distance? Do I have any swing fall? You know, I got to get more, should I be more aware of, you know, here's a clearance height calculator for the Miller Falcon. So if, you know, talking about lateral edge distance and setback distance. So now you're starting to see areas, oh, I can't use it if my lateral edge distance exceeds, if I'm at a 5 foot setback and I'm want to work 20 foot away. I got to be careful. So we can teach you how to understand these charts and how to apply them. But we really want you to start thinking about things differently as you use these retractables. You know, like here's what I was talking about. At a zero setback distance, one of the manufacturers has a 145-inch arrest distance. What's that going to do to your required safe clearance distance? These are the things you need to start thinking about, you know, and how does their chart look differently than the Miller chart or the DBI chart? So we're teaching classes to people that have a variety of products or see a variety of products, how to get to the right end zone. Really, I think the calculator or the app is going to make simple work of all this when we eventually get the math fine-tuned for it to work. But I'm going to end it here, and of course, I'll open it up to any questions that you folks might have. We haven't had any yet, so we might just end with no questions. I hope we get some. And if you want, you got that phone number from slide 1 here. You can give me a call on the mobile number. I'd be happy to pick up, or send me an email. I'd be happy to answer any questions you might have. Otherwise, that's it, folks. I appreciate your time today. No questions? Have a good one, folks.